Oh, sorry, Anne. I will open the QR code later, okay? In the middle of the courses, okay? Okay, so yesterday we are discussing the um, log. So before we move forward to another um, sections of this log and exponent, because I want to know how much do you know, or how you can solve the exponent and log equations. Okay. So I believe you can solve this too. Okay, I believe you can solve this too. But just to check whether you are um, your concept is correct or no. Can you do this all this? So you have, in this case, you have three exponent, okay, exponent form. And please rewrite this form, okay, in logarithmic form. Please rewrite this in log form. I just want to make sure that you are okay with this and we can move forward. Okay, please come in. I will show you the QR code later. Okay. 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 Please rewrite all these three into logarithmic form. Okay. Into logarithm. If you feel that it's too easy, I don't mean to disrespect you. Okay. I just want to check whether you are able to write this in logarithmic form. Hmm? Just write as in number. How about it? Yeah, just write like usual. That's fine. How about you? How about your high school? Do you get log or not? No? Okay. Okay. Uh, okay. Let me write some. If you have this form, okay, we call this is the base. Okay, this is the result, and this is the power or index. Okay, but depends on uh, the applications. Sometimes you can call this time, as in population, growth of population, and this is the growth rate, and this is the total population or numbers. You can say that also. Okay, it depends on you, whichever your perspectives, as long as it is correct in math, uh, that's still okay. So how to write the log? Okay. Log, first write the base here, okay, because every log has different base, okay. And then what is so important about log is from here, okay, from the exponent, you get something a here, and you are powering to b, right? And you get the c. But what is the purpose of log? Okay. Logarithm purpose is to find b, to find the index. So we kind of inverse it. So we write the result here, c, okay, and this is equal b, okay. So if we have 6 with power of 6 is equal to 64, then it's log, okay, 2 and 64 is 6. Okay. And the second one, it doesn't matter if you have the negative, okay. Remember that this chart, okay, 2, 1, 2, 2, 2, 3. Let me write 2, 2, 2, right? 2, 2, 2. This is 2, 4, 8. Okay. What happened with 0? It's become 1, right? Because if you see here, you multiplying with 2, multiply with 2. But when you go up, you are divide by 2. And you divide by 2. That's why it's become 1. Okay. And when you go up one more time, like negative 1, it's become 1 over 2. Why? Because here, going up, it's divided by 2. Okay? Easy to follow? Okay? So that's why when you have the index negative index, you need to write upside down, okay? Or reciprocate. Okay? Reciprocal. Okay? So 1 over 2 and then divide by 2, 1 over 4, or you can just write this means when you have 2 negative 4, this means 1 over 2, 4. Okay? Just a note for the exponent. Okay. So when you write this, the second case here, so log you still write the base is 49, okay? And the result is 1 over 7, and this is negative half. Just write as simple as that. Or if you want to make more clearer the log, maybe you can write this is 7, 7. So you know that this negative 1 over 2 is from this and this. Okay. So when you have a log a, let me write the index. Usually this is n, this is m. Okay. This is equal m. Okay. And this one, yeah, even though you see x, just write the x because the instruction is just to write the log form. Okay. So just write the log form. Log, because it's 10, you can skip the 10 because if you see any log, just log without any certain base. It means it's log base 10. Okay. So log 74 is x. So there's a hidden 10 here, but it's already defined that any log is based on 10. Okay. Okay. Any questions first? Okay, Trevin, wait. Any question first? Okay. Let me go back to the previous one. So Trevin, this is the number one from here, from this slide. Okay. How you solve this? I will show you one way. So first, I will go back. So I will go here. This become 64. Yeah. So it should be 2. Okay. Who answered 64 yesterday? I didn't check. Okay, so it should be 2. Okay. Okay. Thank you, Trevin. I think number 2 is correct, right? 270 divided by 10 is 2. Yeah, it's true. Okay. So this one should be log minus. I will multiply this. Okay. Log. So I can write this as so. If you see this, you want to know what is the answer from here. So the logic is 3 is our base, right? So write 3. How to make 3 with some power become 27. Let's just multiply 3. 1 is 3, right? 3 with the power of 2 is 9. 3 with the power of 3 is 27, right? So it's 3. So that's why the answer for this one is 3. Okay. Okay. Okay, let's go to the next slide. Okay, I believe we resolve this. Okay, let's just check these expressions and check your understanding how to solve this, meaning to calculate. And we don't need any calculators, okay? So last year, I'm still tolerating, okay, you can use calculator because I also giving like difficult calculations to you. But now I think to make math is more basic, so we just get rid of calculators unless we are um, need that calculator. Okay. So try to solve this. Okay. So log 5, which is square root of 5, log 25, log 4, and then the last one is log base 2 of 16 with the power of, yeah, 23. Mm-hmm. Yeah. Oh, here, log 100. Okay. Yeah, correct. So as I told you before, maybe in the first week of both in calculus or in the basic math, I told you that math is a huge world. Okay, it consists of different sections, different chapters. Okay, and calculus is only one of them, and there's also another section in math, in pure scientific math. But because we are going forward to be an engineer, so we are only focusing on the calculus, okay? And this log is actually one part of basic math that you need to um, you need to have the skill and the ability to know what is the meaning of the exponent and log. Okay, math doesn't need any words by words explanations. Okay, you can explain math by graphics. You can explain math by notations, okay, because math use notations. Okay. So if you cannot explain in word what is log, what is exponent, just write some numbers and write some patterns. Then you can get the idea. Oh, this is exponent. Oh, this is the log. Okay, like when you learn how to count, how many apples you have, how many orange you have. Okay. You understand that by practice, right? So this is also similar. So you understand by concept of numbers, how you count the numbers, and that's how you design or how you understand the foundation of math. Okay, this one, you don't know this one? Yeah, like I said before, if this doesn't have, then it's base of 10. But you don't really need that base, right? You just calculate because it's both of them. They don't have any number base. You understand? Okay, how you get this 5? Okay. Okay, I believe you already write all the okay, Vitasha. Okay, good. Uh, okay, but online students, you're correct. Okay. Let me go back to previous slides to you can have some so from this log, okay? If you have the same base and result, you can write this as 1, okay? If you have same base A, you have P, Q. If you have addition, then you are multiplying this PQ, okay? If you have some base A, so P, if you have minus here, so it becomes P over Q. Okay. Another law, if you have some constant n at the front, okay, you can also rewrite this as go back to here. So n can be as the index on P, okay, P with the power of n, okay. And also, you can rewrite, this is what we call change of base. Let me write change of base. So if you have log b over log a, you can have any c you want. Okay? You can change the c because it doesn't matter. It will be log a b. So you can rewrite this. Log base a of b, you can rewrite log b over log a. Okay. So if you have log a b, you can switch and become 1 over log b a. Okay, log base of b of a. Okay, I think this all of these laws is of the basic law of in log, and I think most of the time you will going to use it in log. Okay, okay, let's back to here. So to solve this, first I can rewrite this as 5, 5, half, right? You can bring this half going to the front, and log 5, 5 is 1. So it's 1 half, so it's half. Okay. And this one, remember, any log that you cannot see any base as the number, it's log 10. Okay. So it's actually log 10, but you don't really need to write that. Because if you use calculator, log 5, meaning the calculator will be calculated log base 10 of 5. That's already defined definitions. Okay. So here, log, okay, 25, 4. Okay. So it's log 100. And it is equal to 2. Okay. Why is 2? Yes, 10 squared. Okay. So you can also get the idea. This is from here. You can also going forward to here. Okay. And how about this one? Seems intimidating with the 23 at the index power, right? But the idea of solving this is making the base and the results the same a number. Okay. So 2, so 16 is 2, the 4, right? And then it's 23. And you can multiply 23 with 4, it's 92. So you can have this is, okay. If you're still having hard time solving all this, okay, I need you to review, and I will put maybe some practice. Uh, you don't really need to go for all the questions in the practice. Just go for solving like simple logarithm like this. Try by yourself. Make sure you understand, and repeat all the process. Okay, repeat all the process until you get the idea. Oh, this is actually not too difficult. Okay. Okay. Try this one. Okay. Okay. Remember, ln is log with base of e. Okay. You get it? Uh-huh, uh-huh. This is actually 7, 7, not 17. Yeah, 7, 7. But yeah, your concept is correct. How much this? How you can write to? From where? Can I know? How you can write this? Can you explain? But can you divide those and make two? I think I never told you this, right? You cannot do that. Okay. Okay, correct, correct. Okay, online students. Okay. Yeah, good, good. Okay. Um, if you're doing this, okay, if you're doing this like log 8 divide log 4 and you get maybe log 2, okay, it's forbidden, okay? You cannot do this. It's wrong, okay? The same way when you have, for example, log 4, log 2, log 8, this is also wrong, okay? So remember, what you are allowed to do is log 4 plus, if this is plus, then this is log 8. This you can do. Yeah. And how you know it's correct or no? That's the question. Okay. You can check with the. Let me try real equation. So log 4 4, log 4 16. This you can write log 4 64, right? Or simply you can check. This is 1. This is 2, right? So it should be 3. So let's check whether this is 3. This is 3, right? And that's correct, right? So that's how the law came from. Do you understand? Uh, 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 Even though you are not really answering the question understand or no, but I see who understand and not. Okay. So please check your concept, um, review, do the practice when I give the PDF. If you still cannot really understand until the end of the semester, I don't think you will survive. This is just my advice. I don't think you will survive if you don't this if you don't understand like the basic foundation of math. Okay. You need to um, force yourself achieve this standard. Okay. Okay. Back to the questions here. Let me erase this part. Okay. Okay. So this you can write log. Okay, let's make the same base and results. It's 2 with 2, right? And 8 is 2 with 3. Okay, this is also a concept in log, which you can. So remember that when you have 3 here, you can move to the front, right? So it's become 3. And how about if you have something here? You can move also to the front, but become at the bottom. Okay, so you can write this as 3 over 2, meaning 3 multiplied by 1/2. 1/2 is from this, 3 from here. So you can write, if you have n, a, m, so this become m over n. Okay, but remember the requirement. You need to have the same a here. Then you have the m over n. Okay, got it? Another one here. It's also we can write some law here. A log a, this is b. The law say that we can write this as b if you have the same a, okay, the same base with the indexes. Can you prove it? Maybe the way I prove will be like this. It's equal to y. And let me write log base of 2, log base of 2. And make all the log 2, 13, log. Let me write with the, just by definition of log. I think it will be better. So it will be log 2 of y is log 2 of 13. Okay, that's better, right? So you can see this is the same. Okay. So you can write this as just b. Okay, so it's the answer is 13. Okay. And how about the third one? You have e. Okay, remember ln is log with base of e. So if you have ln 7, you can write this as log e7. Okay. And to solve this, because ln is the same as log, right? It's log e. We can remove 2 going here. So e ln 7 squared. Okay. But because this is also e log e7 squared, you can say that we can cancel this and it's just 7 squared or 49. Okay. Okay. So this week I'm planning the basic math for exponent and log will be very basic. Next week I will try to move to a little bit complicated. Okay. But before that, I just want to check um, this one. Okay. If you have any exponent or log in equations, okay, and you have the x inside, and you need to solve for x. based on exponent law and the log, and you try to solve the x. Mhm. Okay, good, Stefan. What is the second one? Remember, number B is only one number. There should be not two answers. You need to check, okay? You need to check. Yes, yes, correct. Of course, if that's not in the domain, then you need to choose which one. That's why in the early weeks, I always told you domain, 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 because if you don't understand the domain, you cannot solve the whole problem in math. Mm-hmm. Yeah, just write log 12 and then, okay, same base, right? So the inside should be the same. Then you just equaling this inside. Yeah, and solve the x. Okay, you have two, right? But is that correct? If you use -2 here, it's log -4. Yeah, so it's only having one answer. Yeah, okay, okay. Oh, this is this. If you use this -4 here, can you do it? Log negative. Is it possible? Right. So you just one from this. How you solve this? No, you don't need to change to log. No need to change to log. Can you solve this one? I didn't write previously, so you need to figure out yourself. Yeah. Can you do it? No? No? Okay. Then I need to be honest with you, okay? You have a long way to go. Yeah, yeah, and you need to, I don't know, maybe find like maybe a group discussion for exercising, okay? Because I don't think the class is enough to understand in short time. You need to have like maybe looking for a senior if you knew someone who can at least teach you the basic one. So the idea is to make the in the form of exponent. It's 3 with something, and this is also 3 with the 3 with power of 3, right? So it's the same exponent. So the index is the same, and you can just equal in the power. Okay. Yeah, correct. So Trapin, you cannot have any log um, negative. Okay, I think number one is just making the same or equaling the exponent. Okay. So the 3 to x minus 7, this is 3 and 3, right? So because it's the same exponent, you can just focus on the index, 2x minus 7 equaling 3. So 2x is 10. So x is, okay. Number two, remember you have additions. So you can multiply the log inside. So log, you can write x plus 1, and then equal log 12. I will just expanding the x, and because it's the same log with base of 10, right? So I'm just focusing on the inside here. So I will write x squared plus x equal 12, or we can solve this as our quadratic function. X squared plus x minus 12 is 0. So we can have factorize this to x minus 4 plus 4, x minus 3. Okay. So from here we get x minus 4 or x equals 3. But is our calculations stop here? We need also to check domain. Okay, domain, because if it is not in the domain, then it's not our answer. So let's check the negative 4. Check negative 4. So log negative 4 plus log become negative 3. It's log 12. If you use any calculator, you try until the end of time, you will not get the answer. It will become error. Okay, because log cannot be negative. Okay, so this will be incorrect. Okay, so remember, if you need to find domain in log anything, the inside need to be greater than 0. Okay, that's the first case. Yeah. If you want, maybe let me show you the graph so you can have better understanding. Okay, so input the log. Let me just input the lnx. Okay, and then input the e to the x. Okay, so from this graph, okay, So this one, okay, the right one is our log, okay, and the left one is our e to the x, okay. So when I say it's inverse, it's practically mirror each other. Okay? You can see if you have split this into like having one line here, the e to the x is basically the inverse of this log. Okay. So you see in this log, okay, it's cross one here. So when you have one, it's 0. But see when you have the x is negative, you cannot passing through here, right? So you cannot have any x negative, okay, for the log. Um, I think this is also good concept for you to um, not memorize, but try to understand because it's not too difficult to draw, right? How to draw is just remember this one and maybe taking some number here. Um, maybe in some part in between 2 and 3, it will become 1 because it's e. Okay, so yeah, there's also good visuals to understand which x that should be in the domain. Okay. Okay, so I will close this. Yeah. Mm-hmm. What? Mhm. Uh, it will be going further to infinity. There will be no other way. Mm-hmm. Mm-hmm. Yeah. Mm-hmm. Yeah. It's different because you see the infinite one is the negative, right? It's on from, yeah. Yeah. It's not the x. Okay. Let me continue a little bit about the. Okay, maybe some try some. Do you, uh, if you understand the concept or no? Okay. So the question is which one is larger? So A, B. So right, uh, is this or this? Okay, and do not use any. Please don't use calculator. From what you are, um, from your understanding of log, okay, can you conclude? Can you make a conclusion? Which one is larger? Okay. Log base 4 of 258 or log base 5, 620. Seems this is bigger, right? But is that true? Can you prove? Me, but the Negative. Which one do you think? Yeah, but can you prove it? Yeah, okay, okay, okay. Mm-hmm. Mm, how? Oh, okay, 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 okay. Really? This is hmm, 5 power 5 is what? No, well, no, no. This is what? Yeah. Okay, okay, okay. Mm-hmm, mm-hmm. Me, yeah. Me. Yeah, yeah, yeah. Yeah. Which one is larger? This one, right? Okay. Yeah, this one, right? Yeah. Okay. Good. Don't have an idea. Okay, the idea is not to calculate this number directly. Do you understand the question? I think I think you can have like several way to prove. Yeah, if you can calculate without calculator. Yeah, but you get the near one, right? Yeah, you can use that. You can use that as your conclusion. So do you think A or B? Yes, around, yeah. Yeah, yeah. Okay. Okay, who's A? Who is A? Okay. Okay. Okay, who's B? B. 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 Okay. B. How you are proving that? Oh no. Okay. Okay. Who's B? How you are proving B? Okay. Okay. Here's uh some solutions. Okay. So you don't need to be able to exactly calculate this numbers. Okay. You can actually approximate. Okay? But if you can do the calculation, that's fine. But let's start with this log 4. Okay, is there any 4 that getting closer to 58 to 56, right? It's around 4. Okay, so if you have log 4 to 56, it's less than. Okay, that's the first case. And then the other one, log, let me write the exponent 5 with some power closer to 620, 625, right? It should be also 4. Okay. So from here, um, log 5, 620 is less than log 5, 625. So this is 4. This is 4. So you have the conclusion because this one meaning bigger than 4, right? So you can write this as log 4 okay. Even though you are intimidating by the 620, but remember it has different base in log. It's can cause significant amount. Okay. Okay. The next one. Can you try to solve this? Let me write the other questions. Try number 1 first, and if you finish that, then try number 2. Okay, for fraction, is there any log formula for -2 with the power of 3, -8? I don't think it's possible. Okay. Yeah, A1, B1. Okay, good. Okay, correct, correct. Number one is this. Number two. Mm-hmm. No idea how to solve it? Here, if you have like this 3x, 3x, you can change the 3x to any variable like x or y. No, 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 no. What I mean is 3 to the x, right? 3 to the x is a or b or no, no, no. 3 to the x, just equaling b and change to b all b. Here, here. 3 to the 3 to the x, that's just a or b. Okay. Now, can you change all into a? Change the this variable. No, 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 no. 3 to the x is a. Okay, you get it? Get it? Yeah. No, no. It has to. Hmm. So a? No, no, no. Oh, long way to go. This a. Okay, it's the same as this, right? So it's can you solve it? And then later change back to the original. This is which this one? Oh, that you change to log. But can you make the six go here? I don't think it's possible, right? So don't use the log. Just use the exponent. You can solve it just using exponent. You got it? Mm-hmm. This one, okay. Just take example, okay. 3 to the x, this has also 3 to the x squared, right? Same, right? Can you change this 3 to the x to another variable? Maybe you can have a as your 3 to the x. What will happen in the function? Yeah, and change all to a. Can you do that? So if you have 2 here, the 2 becomes the square, right? Yeah, yeah, minus 6. Yeah, can you solve it? Okay. Mm-hmm. Mm-hmm. How? How? This one? And what is? Uh-huh. But you have still this 2. And how you divide? And how this become 2x here? But you want to make it like equaling left and right, right? Is that correct? What power you can get to make 0? What tree of power you can get to make 0? 3. 3. Do you get my point? Here, you want to make this like 3 like before, right? Like this one, right? It's 27. You can make this 3, 3, and then you can make this equal, right? Yeah. But it's 0. How can you make that? 0. So 3x 0 solves it. Can you solve that? If you cannot solve that, then your whole concept here is wrong. Okay. So you can check like one by one. Okay. You can check one by one. If your concept is not true, it's kind of impossible to do, then that method or that concept is wrong. Let me write here for you. If you make this 3x is, let's say b, okay? If you have 3, 2x, what will be? If this is b, how to be? Step by step, okay? Look here. I can write this as same, right? Okay, so I can write this b squared minus b minus 6. Can you solve it? Mm-hmm. Okay, here. See, the problem is here. This is not the equation is not this. So the equation is this, right? Okay. So the problem is maybe this one, right? How to solve this? Okay. So if you have like problem like this, assume any variables. Like if you want to make this as a, okay, then this will be a squared, right? Is that correct? Okay. So I can write a squared minus a minus 6 equals 0. Can you solve it? Hey, this is quadratic functions, just normal quadratic functions. Can you solve it? This? You cannot solve quadratic functions? Hey. This is really basic, okay? Okay, then you need to rethink your study here. This is really basic, okay? This right? One, right? Yeah. How about it? You get it? Uh, yeah. The maybe you can check this number. Yeah, this is this one, right? You need to change to the original tree and find the x. Okay, this is not complete yet. Okay, so number one is, what is the answer? One, one. Okay, number two, one. Okay, who's still confused? Number one. Number one. Okay, right. Number two, who's still confused? Number two. Okay. So number one, I will write for you. How about the online students? One. Okay, okay. But I hope you understand the concept. Okay, for the online students. Okay, who else got one? Okay. Okay. So the problem is the exponent here, the 3 with the power of x. Okay, so let the 3 with the power of x is equaling some number a. Okay. So if you have 3 with power of 2x, you can write this as 3 with the power of x and squared. Okay, and you can write this as a squared. So a squared minus a minus 6 is equal 0. Okay, you can factorize this. Okay, x is what? Minus 3 plus 2. Oh, no. It's a. Okay. So a is 3 and a is negative 2. We need to check. Okay, so we need to bring back the original equations. So a is 3x is equal 3, which is x is 1. Okay, and this one, it's not true. Okay, it's not possible, right? So x is 1. And number 2, okay, the problem here is also there's too much log, right? Log 2 squared, log 4, log 5 squared. Okay, but if I change the equation a little bit, okay, let me write this log 2 squared plus I will change this to 2 squared. Okay, and I will move to the front, so 2 here. So it's become 2 log 2 log 5, and then plus log 5 squared. Okay, if I change this, can you see any pattern here? Okay, if this is A, this is B. So this is 2AB, right? It's squared squared. Okay. So you can also write this as log 2 plus log 5 squared, right? And this is what? Log 10 squared. Log 10 is 1. Okay, you get it? A little bit tricky, but if you get the pattern, then you can solve it. Okay. Okay. Any questions? Any questions? Okay. Does the second part make sense? The second number 2 make sense? Okay. Um, let me move to another sections. It's called the solving logs with we call pronumerals. Pronumerals. Okay. So what pronumerals means? Uh, I will just give you some examples. Okay. So if log 6, let's just say 6. Yeah, log 6 is A, and then log B, log 108 is B. Express log 3 and then log 54 in terms of A and B. So meaning pronumeral means you can have your log in any symbols or variables, and you need to express another log with that expression. Okay. So the question is log 3 is what? Okay. Based on your information, log 6 is A, log 108 is B. And then the second one is log 54. You can try and look for any relations first between A and B. Okay. and how to get to 3 and 54, maybe plus, minus, multiply, divide, and so on. Yeah, online students, you can also try expressing the logs in terms of A and B. And if you think the course is too fast, just let me know. Okay? And maybe um, which sections you are still confused with, please let me know. You need to try some, look for some relation and make the conclusions. Have you seen this kind of question in high school? No? Really? No? Huh? Log. Oh, okay. Yeah, but it's similar concept, right? Similar concept, okay. So I remember I'm doing my exam in high school and yeah, this kind of questions. Hmm. Ya, cari-cari relasinya kan macam-macam tuh. There's no answer in the. Did you get the questions? So uh, the log 6 is A, log 108 is B. Okay. So the question is asking what is log 3 and log 54 based on A and B. So you need to find some numbers, how you get 3 from this and this. Yeah. Yeah, maybe you need to find how you can get 3 from 108 divided by what number. And from there you can write down some relations. Yeah, how to get to log 3. You still have the log 2. You need to have another AB here there. Mhm. Yeah, you still have this log 2, right? You need to change the log 2 into AB also. Yeah, it's still uh, how this 54 here? Mm-hmm. Yeah, yeah, but it should be log, right? It should be uh log 108, right? So 108 and it's B. So B minus But you need to change also this one into the AB also. So you need to remove any number. Yeah. Ini dong. Nggak bisa dibagi dong. Nggak bisa dibagi dong. Kurang kali. So, do you understand the question? So you don't really need to calculate like really looking for the number. So what you need to do is you need to looking for log 3 from log 6 and log 108. Okay, and you need to make all the answer with A and B only. Okay. Okay, so online students. Okay. Okay, you're correct. To log 54 is, I think you got wrong in log 54. Log 3 is correct. Log 54 is, I think you had some mistake in calculating the A. Okay, so log 3, what is log 3? B minus A squared or 2A, right? Yeah. Almost. Okay. B minus 2A. And log 54, 2B? Oh, 3A. Okay. Okay. So we can start with the um, this log. Or let me write this first. Have this. This is log 18. Okay. Log 18 is log 3, 6, right? And log 3, 6 is log 3 plus log 6. And this is, we can write log 108. Okay. So we can solve log 3 is B. So minus A. So minus 2A. Okay. So this is B, this is A, this is A. This is the answer. Um, yeah, that's right. Yeah, try to find relations. You can start from anywhere actually. And log 54, you can start with log, because it's half of 108. You can start from this. Let me write in the new page. And then this become log 108 log 2, right? So log 108 minus Um, I can write this log 6/2. Is that correct? It's 3, right? So log 6 minus log 3. Log 3 is b minus. Let me write this. So to be, yeah, okay. I will give you the last questions, and maybe if we don't have time to solve it, we can solve it next week. Okay. It's 3 log base of 3 log base of 3 log base of 3. Try for maybe 5 minutes. Cannot solve it. I will solve it next week. Or maybe I just need a couple of minutes to solve. So it's 3. It's a constant. Okay, constant. 3 log base of 3 log base of 3 log base of 3. This is the result, not the power. Okay. It seems so intimidating. You get it? Okay, good. Good. I think, yeah, I think you're good. Yep. Okay. Is it too difficult? Okay. And this is going difficult now. Yeah. Yeah. Hmm. Why is this appear? Gimana? 30. Gimana berapa? Sepertiga. Tiga loh. Kalau tiganya kemana? Naikin kemana? Mhm. Mhm. Ya ke sini. Terus kalau tiganya kamu ubah ke bentuk 3 pangkat 0. Benar. Mhm. Sepertiga itu 3 pangkat berapa? Nggak pusing ya? Bisa, bisa nggak? Nggak bisa nggak? Hmm. Hmm. Oh iya di Indonesia gitu ya. Diubah aja deh biar sama ya. Diubah aja ya. Rumusnya. Kalau dulu juga saya pertama ngajar gitu terus pada bingung saya ubah aja sesuai sama sih. Yeah, correct. So who solve? Okay. So who else solve? You got it? Yeah, 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 yeah. You just need to remember the idea of the basic log, the basic log from the first rule. Remember the a with the power of b is c. You write it from into log. Can you rewrite this into that form? Yeah. Okay, it seems so stressful. It's like a monster, right? So many layers. So the idea is having layers. Okay. See, you have log, 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 right? It seems like cutting an onion. You have like layers by layers by layers. So let's see this log as layers when you cut onion. Okay. See this first. Okay. The first log at the front. Okay. You have a constant tree, which is actually that just meaningless, right? You can just remove this tree. Okay. Because you can divide by 3 and it's the 0, right? So you can just remove that. Okay. So still you have log base 3 with this huge monster here. Okay. If you feel intimidating, just make this y. Okay. Or maybe another variable. So you can have log 3 and the whole thing inside is y. It's 0. So base 3 with power of 0 is 1. So y is equal 1. Okay. So the inside become 1, right? The same thing with this whole method. You can make this x log 3x 3 with the power of 1 is 3. So this one is equal 3, right? So here, okay. So let me write this x, okay. So log 3x is 1. So 3 with the power of 1. So I will write the conclusion here. Let me write the conclusion. Log 3x is 3, 1. Okay. So 3 with the power of 3 is 3x. So x is 3, or 3 with the power of 2, which is 9. So you need to start from the outside of that log, okay? And move to inside. Do the same thing, just using the first rule of log. Just using this A, B, C, right? Log A, C is B, okay? Just using this law, you can analyze and observe this whole log, any log inside change to the basic law here. Use this law. You have log 3, and this is actually the inside log that has many logs, and it's equal 1. Okay, so your whole sections here become 1, and do the same thing here. Make this x, and the conclusion is log 3x is 3 with the power of 1, right? 3 with the power of 1, base 3. This is the power, okay? 3, 1, okay? And from here, 3 with the power of 3, okay, is equal the result 3x. Okay? Just using this basic rule. Okay. So from now on and next week, the things will get difficult. The things will get more complicated. Okay. I will make like uh, more examples, and it will be much more complicated. Actually, in your textbook, in your pre-calculus textbook, in basic math textbook, we don't really have that really complicated one. We have like some complicated questions, but most of all it's quite average and general. But because I need to prepare you for the whole calculus subject, okay, I need to go deeper in the examples and questions, okay, so that you can have more, or you can be prepared more for this calculus and next calculus. Okay. So next week we will still going for log and exponent. Hopefully I can finish next week. Maybe on Wednesday I just finish half, and then we go to the next section, which is the trigonometry. So I will stop here, okay, for now, and we finish our class. Okay. Okay. Thank you, online students. I hope you understand the concept of log and exponent.